Hi guys, this is your instructor for the Programming 2 with C++ class, CAC 2144. I am making this video for our class as well as for future classes for the chapter 8. So if we go to the modules, we have chapter 8 covering in the modules following chapter 7, which is what we covered in week 2 as well as in week 3, and starting with week 4 and also for the week 5 we'll be covering chapter 8. So although I have posted some helpful videos from what I could find on internet, I'm making a video which is going to be a video lecture as well as assignment help for chapter 8, and it will be posted just like this under the week 4 and 5 so that you can use it, watch the video and understand what you need to do. It will help you with doing the quiz as well as the assignment homework for this chapter. So let's get going with the ebook. Because I'm having an ebook, I can show you all how it will the content for this chapter relates to what you will be doing. So chapter 8 is titled as Arrays and Strings, and if you recall, in chapter 7 we touched briefly upon strings, how we can use strings to capture text, as well as a whole lot of functions that you can use on string: to copy the string, to erase it, to check if it is empty, to concatenate it, to take a part of it using substr function, and so on. In this chapter we'll be covering two of the things, which one of the two things is strings, continuation on what we learned last chapter, and a newly introduced topic of arrays. So you will learn why we need arrays, how to explore and manipulate data in the array, what's the meaning of the array index out of bound, learn how to declare and initialize array, become familiar with the restrictions on array processing, and there are just few restrictions as such, discover how to pass an array as a parameter to a function, an extremely important point, the point number 6, how to search and sort array, become aware of the auto declaration, which is an important element as well, how we can use the range-based for loop, and what about the character strings or C strings, and examine the use of string functions to process character strings, and discover how to input data and output data from a C string, learn briefly about parallel arrays, discover how to manipulate data in two-dimensional arrays, and learn about multi-dimensional arrays. So the last three topics will be very briefly touched upon, but primarily we'll be focusing on arrays and strings in this chapter. So as you have learned, in the last chapter, in the previous chapters, we dealt mainly with the simple data type, the primitive data type, the integers and the booleans and the decimals and so on. So that was simple data type, where you can only store one value. But when you're talking about structured data type, we can have n number of values in that collection. So this is what we'll be learning. Let's just imagine that you're writing a program where you are asking the user to enter 5 test scores and you're calculating the average. So this is an extremely simple program. We have include statements for the IO stream and IO manipulation. Then we are using the standard, using namespace standard, so that we don't have to keep using the word standard again and again. We have our main function declaring 5 integers and one double variable. We are setting some standard for how we are accepting the data, and then we are asking the user to punch in 5 numbers. So we calculate the average and we display the average as to say the average is this, and check how many of those 5 numbers were less than the average. So here we have some if statements, one-liners, where we are checking the number, the first one, the second one, and third one, and the fourth and the fifth, to see if they were smaller than the average. Now the problem, or the point they are trying to convey here, is that if you are asked to do 5 numbers, you can easily capture 5 numbers in 5 variables. But what if the user only enters 4, and in the fifth one he or she doesn't have it? Then the average will be skewed. Similarly, if you are asked to calculate average of 500 numbers, are you going to declare 500 variables? That doesn't sound correct. That would be unwise. A very practical example that I can give you is when you're reading a file, The file can have 1, file can have 10, file can have 1,000 or 1,000,000 records in it. So how do you foresee and create that number of variables in your application so that your application behaves properly? Well, we cannot do that with the simple data types. We need to look at the structured data type, or what we call arrays. An array is a collection of fixed number of characters, also called elements, all of the same data type and in continuous memory spaces or contiguous memory spaces. They are stored one after another. We'll be learning more about it in a little bit. So one-dimensional array is basically a list of elements that are going to have some values. They will be stored in the memory one after another, and depending on the data type, we will allow the array to be filled up with the same data type for all its elements. How do you declare an array? Well, in the last page you saw we have int, test0, comma, test1, test2. So there are 5 variables we are declaring. The data type is in the beginning. When you declare an array, you basically have the data type, the name, and then you use the square brackets to specify how many elements you will be having in the array. So that's the example of how do you declare a array. And here is a concrete example where we are saying we are going to have an array of numbers which will contain 5 elements. So we'll have 0, 1, 2, 3, 4, y0, because that's how C++ starts the indexing for the first position and onwards. So we'll have number 0 is what we will call an element within an array. It's one of the elements in an array, and the numbers will be stored as follows. So we'll have a number array, number 0, number 1, 2, 3, and 4. So from 0 to 4, it will give us the 5 elements in an array. How do you access array element? As I was saying earlier, if we need to grab the value or set value into a particular element in an array, this is how we will do it. So imagine you have a list array which will have 10 elements, so starting from 0, and that's the array subscripting operator. We are using the square brackets to specify, hey, I want an array of 10 integer elements in my computer memory, and this is how they'll be arranged in your memory. When we are saying, hey, I want to set the 6th element with the value 34, now when I'm using in this array subscripting operator and setting the index of 5, please understand, as shown in the figures here, we are talking about the 6th element. So 6th element will be saved with 34. If we say third, then that means we are saying the 4th element will have this, and so on. Now here is an example. We are saying the third array position, or excuse me, the 4th array position will have 10, and the 7th element in my array will be 15. So the 6th element, which is with the subscript number 5, will be addition of 10 plus 35, because that's what we are doing, and that will have 45. So as you can see here. There are multiple ways you can manipulate the index position of the array. So in here, if I is 4, then the assignment statement list 2 times I, which is 2 times 4, that is 8, minus 3. So 8 minus 3 is 5. That means we are saying the 6th element will have the value 58. So it's just different scenarios will result into different circumstances where you will not specifically set a number as you are doing here, but having a for loop, and you are using the for loop counter to increment the index within the array and setting the value in the individual element of the array, or getting the value from individual element in the array. So here's another example. You're saying, hey, I'm going to have a constant in my code, and the constant is array size, which will be set to 10, and when I'm declaring my array, I'm not going to enter a number 1, 0. I'm going to declare array size. So internally I'm just saying I want an element, an array of 10 elements, which is what we are doing here. So in this snippet that you see here, we are saying I am going to have an integer variable, and I'm going to get the value from the user, and whatever the value user enters, I'm going to make an array of that many elements. How do you process an array? As we were talking briefly, you can use a for loop, and if you know how many elements are going to be in the array, you start from 0 and you go until 99 if the array has 100 elements, because remember the index for the array starts from 0 and goes until the 99th position. Okay. Similarly, here we are saying that, hey, I may use a loop and I'm going to run from 0 to 99 incremented by 1, and every time I run it, I'm going to ask the user to enter a number. For example, you have to hypothetically conceptualize the situation. Here we are using cin, so we are asking the user to input something and we are setting the value in the ith position of the list array. So I starts with 0 and goes until 99. So we will sequentially capture the data. Similarly, we can sequentially display the data back to the user as it's done here. So here is an example that they are using where they are demonstrating where they are going to do different elements, and as you're reading this ebook with me or reading your book with me, try to understand how it's being done. So here we are going to initialize an array, read the data into an array, print the array, and find the sum and average of the array. Lastly, we'll find the largest element in the array. So keep in mind how they are doing, because point number C here as well as point number E here will help you with the homework that I have for this chapter, the programming assignment that I have for this chapter. As in, how do you find the largest element and the index at which the largest element is present, and find the smallest element, and how do you find the index where the smallest element is present. We will look at that a little bit later. So here is a conceptual example that if you have the index as follows, and here are the max index, how it will work and how it will evaluate that if condition which was given in the previous page. The coding, for example, 8.4 shall help you understand and further reinforce what are the topics we are learning here. We have an array of 5 elements, and then we are asking the user to enter 5 scores. As the user is entering, we are summing the score. So one after another, we are adding the scores. In calculating the average, we are dividing the sum by 5, and to find what elements are less than average, we are saying, hey, let's run a for loop from the first position, which is 0, until the last position, and if the value in that particular position of the array is less than average, then we'll say the 10 is less than the average test score, or 20 is less than the average test score, or something like that. So you can see how it is going to display the output here. Now we are using test in square brackets index. So what you're saying is it will generate an output such as the following: 62 is less than the average test score. You can also do that. You can say, hey, the element at index, because index is going to tell you where the element is, so it would say the second element, which is 62, is less than the average test score. So you will not only display the score but also the location at which, by utilizing this index, which is going to tell us if the value is less than the average or not. Now, if you have an array with 10 elements, you are going to, as you learn that, you will have the index runs from 0 to 9. So if you are having an array such as test with 10 elements, you will have test 0 until test in square bracket 9, because those are the 10 positions in which the data is going to be saved. If you try to use test in square brackets number 10, then you are saying I am asking the computer to give me the position of the 11th element. But when we declare an array, we specify how many elements are there. So in this example, if your array has 10 elements, their index will run from 0 to 9. And if you try to find an element which is in the next position, you will get what is called array index out of bounds. So this is very popular exception in most of the object-oriented programming language, including C++, where if you try to find or try to use an index which is not in the range, we'll get index out of bound exception. And that is a programming error that happens quite a bit. So if you are using having an array of 10 elements and you are saying run the index from 0 until 10, you see how this it's saying equal to, so it's not saying less than 10 but it's saying less than equal to 10, and it will cause the array index out of bound exception to happen. Okay. There are some examples that you can use to learn further about it. When you're declaring an array, you can use the curly braces and initialization operator, the equal to sign, to immediately not only declare but also initialize your array. So this will initialize the 5 positions, 5 elements. You can also say, hey, I'm declaring an array called sales and it's going to have these values. So you're not saying what's the size, but by giving 1, 2, 3, 4, and 5, you're saying internally, I am implicitly I'm telling the compiler that I need an array called sales, and it'll have double data type values, and there will be 5. So position will be from 0 to 4. You can also do partial initialization. So take a look at this. These are some of those edge cases scenario, if you may, whereby you can learn. These are not so common. So here we have an array of 10 elements and we are just saying 0. So what it'll do is it's going to declare a list of 10 elements and initialize all of the components to 0, excuse me. If you have something like this where you're just saying I have an array of 10 elements but I'm just going to give you 8, 5 and 12, so first 3 will be 8, 5 and 12 and rest all will be 0, because in case of integer the default value that is assigned to an integer variable is 0. Here we are saying I want an array of 3 elements and here are the values. If we are saying I want an array of 25 elements but only have 4 and 7, the first will be 4, the second will be 7, and rest all will be zeros as explained verbally here. In this case, what we are doing is we are saying I want an array of 10 and I want to initialize the first position, the second position, the third, and leaving the fourth and the fifth position. This is illegal. We cannot do that. We have to, because the memory that are allocated to array are contiguous in your computer's RAM. We have to specify the values in the order. We can't skip a position, so this would be an illegal. So if you have an array where it's an integer array and you are declaring, values, and you have another array of integer with a different name, one may imagine that we can use the first array and put it into another. But this kind of aggregate operations, like having an integer x and integer y, and if x equal to 5, you can just say y equal to x and y will also become 5, because we can use assignment operator, on two simple data type, but on an array this is illegal. We cannot do that. In order to set the values in this your list from my list, we need to use a for loop and set the values one at a time. We cannot do that. To copy an array, we have to do something like this, or use a for loop, as I was saying. Similarly, for displaying an output for an integer, we just say to get a value within a integer variable, we just say cin and then specify the name of the variable and the value goes in there. You cannot use an array to get values from the user. You have to use a for loop in order to loop through the different elements of the array. Similarly, you cannot display the output directly for an array, because what it would do is it's going to display the memory location of the first element or the base address of the array to your output. So this is not going to work. We cannot also compare one array with another, even though they may be of same size and same data type. This is not possible, because what it would generally do is, if my list was declared in your code in the first before your list, then the memory allocated to the my list will be smaller, and compared to the memory allocated for your second array, which is your list. So it will always be true and therefore it will not function as you would expect it. Okay, we cannot just compare two arrays one after another. When you're passing an array to a function, it always passes by reference. This is something you need to know. You do not have to use the special ampersand sign when passing an array. It always passes as a reference. So if you, so to speak, mess up the array elements in the function, then it will also impact the values in the main method or the other function where you are calling your secondary function. But what you do is, you usually, when you are passing an array, you pass the array and you also specify the number of elements in the array, because when you're passing an array, the C++ sends the base address of the array, the base address where the array starts. And by saying that my function takes an integer array and it also takes the number of elements, you can tell this you can allow this initialize function to use a for loop and loop through the array elements. If you do not send the size, you have no idea how many elements are there. Even though you are sending an array, but you cannot know how many elements. So you have to send the array and how many size from the caller function, from the calling function over to the function that is being called. This is an important element when you are considering working with array. So if arrays are always passed by reference, how do I prevent it, the function where I'm sending the array to mess things up? You can use the special keyword or the reserve word const. By doing so, you are not going to send the original memory locations for the array. Excuse me, you will send, but you will not allow this function where you are sending the array to modify, because you are sending as a constant. So some of these examples are very important. Here, the same reiteration of what we were talking earlier, where if you are sending an array to another function, you have to send the size, allowing it to read and process it. In this case, they are initializing it. Here we are filling the array by asking the user, utilizing the cin console in operator to get the values. Here we are using the function is print array. We are sending an array and the size of the how many elements are in the array, and then we are displaying. So these are extremely important. I want to mention, clearly to you all, if you're watching my video, how the print array is done, because when you're doing your homework assignment, you will need to do something similar, if not exactly same, and that's a hint. Some more, let's go one back. We have the sum of array, which is the name of the function as well as the body. The largest index you will learn, please pay attention. This is one of the things you will be doing for your homework, so keep in mind. And here, the last but not the least, you have two arrays where you're saying I am list1 and how many elements are in the source, and then you have list2 and then the target and then number of elements. So you're starting a for loop where you are copying the values from the first position into the second position, utilizing the source and the index as your element position, and running it until your index is less than the source plus number of element. So there you have it. Base address of an array and array in computer memory. So this is how I was talking about. This is a picturization of how the array is stored in your computer memory. The first, if you have an array like this, the first position will be at the index 0. You will have the number of memory units or bytes allocated depending on the type. If it is a byte, then it will be reserved 4 places, and then you have the second element which will have another 4 contiguous array positions, and then the 4, and so on and so forth, which is what we were talking here. If you just simply try to do something like this, you're just saying, let me just spit out what my list is going to do. That's the name of my array. It's going to display your the memory address of the base address of your array. Similarly, like I was saying before, if you declare my list in your code before you declare your list, then my list position will be less than your list, and it will always run. So go through this and you shall further see what I'm talking about. Some more examples of what we were talking about, where you are sending an array to another function and you are specifying the size. So if you change the second position in this list, then you are modifying the function. The function here is going to modify the second element in your array. Okay. Functions cannot return a value of the type array. So this is one of the limitations. A function cannot return. It can absolutely take as many arrays as required, but it cannot return a function array back to the calling function. Here is an example where you're just sort of capturing how much distance is travel in 10 unit of time, so 10 intervals, and you are displaying the information back to the user. So kindly go through this. This is just an example of how we can use array in a somewhat of a practical scenario. Same concept. They are just reiterating. Sometime we are using to calculate some element, sometime we are using to get the information, sometime we are using to display the information back to the user, utilizing some of the other concepts you have learned in the past, such as the following. So you are doing a tabulated tabbed output of information back to the user. Now you can always use a integer to declare an array, such as my list 5. So I'm declaring an element of 5, an array of 5 elements starting with the index 0 to 4. Now you can also use enum to declare the array indices. So if you have an enum called paint types, green, red, blue, brown, white, orange, you have 1, 2, 3, 4, 5, 6, and 7, and you're saying, hey, I want a double paint size with 7 elements, then you can use paint type paint. So you are declaring paint type as paint, which is a variable of this enum paint, like we learned last time, and you can really utilize something like this, whereby you're saying that I'm going to use a for loop where paint will start from green and paint goes until yellow, the last, and then we are increasing by using static cast so that we can move from the first enum position to the second and third and so on. And we are saying, okay, in the paint sale for the paint, which is the paint type enum, so for green set it to 0, for yellow and red and blue and all set it to 0. So if you were to say paint red equal to paint sale red plus 75, then 0 plus 75.6 will be deposited in the second element, or the second the one index position, which is much more easy if somebody is working in a paint environment where they are not willing to they are not using these arbitrary 0 and 1, 2 positions, but they are using some names which will help them easily track their information. How else can you declare? We learn about this concept where we can use a constant integer and then use it to declare. We can also use type def. So you have int. We are using const int, and the size is the name, where we are doing 50, and then we can use type def double list size, and that would declare an array of type double with 50 elements called list. But we are using type def, so using list as the word, we can declare our own array. So your list will be 50 size and my list will be also 50 size automatically. These two lines, which are numbered as 3 and 4 here in this code snippet, are similar to doing like this. But sometime you may use it, use the type def rather than just literally declaring the array as you are seeing here where my mouse is moving. You can do sequential search or linear search. That means if you're looking for element 18, we'll say, hey, check the first position. Is it 18? No. No. Check third, no. Check fourth, 18, yes, then you exit out. So you can use a for loop and you're just starting from the first position until the last position to keep going and going and going until you have found the element you're looking for, which is exactly what they're doing in this algorithm, as you can see here, as well as in this function where they have a sequential search. And most of the new programming languages, they have these functions built in to search, which would give you the position where the element is present, and if it's not there, then they return -1. So you know that if the value returned by this function is -1, that means the element I'm trying to find is absent. But here is, if somebody were to say, how would you write a sequential algorithm for an array? Here you have it. You're going to send an array, you're going to say how many elements are there and what you're searching for, and you can use a while loop which will go until the array is exhausted and it is not found. If it is found, then it will immediately escape or break out, or if the element of the array are exhausted and still not found, then it will return that found is false. So this is an example of how you can do it. An entire list of the code can be seen here for a sequential search in an array, which is an extremely popular thing when it comes to computer science discipline, where you may be writing these functions to demonstrate how you can do linear search, how you can do bubble search and bubble sort and binary search and so on. So these are different concepts you may be learning in future chapters, future classes you may take. How do you sort? You can do selection sort, where you are just checking the first and the second. If they are not sorted, then you swap them. Then you go first and third, and so on. So we'll see that shortly. Here we have it. So you are basically, if your list is something like this and you're sorting, then you will, this is the unsorted list, we'll find the smallest element, move it to the first position, and the first position goes back. Then we have, again, we'll run through it, we'll find the second smallest position and move them and so on until we have a totally sorted ascending order array. So we'll find the location of the smallest element, move the smallest element to the beginning of the unsorted, and the beginning position goes in that other position, and we keep going until we have sorted. So whenever first time we will start from the very first position, the second time we will start from the second position onward because we have already found the smallest number, and then we'll get the second time, then third time our search will be from the third position onwards and so on. So every next time we are doing, we are sorting one less element because we have already found the previous smaller number, which is what we are doing here. This is an excellent example which can help you learn this concept. Please go through it because you will see how it is done, and I would highly recommend you go through the code in a with a simple examples that you can write down on a piece of paper and then see how it works, and also try to debug it because it will help you understand how it's working. Use some cout statement to see how many times the for loop is running when you are doing or the nested for loops are running when you're running your code, because that will give you a perspective on how efficient this is and how much is happening in these few lines of code. Okay. Auto declaration and range-based for loops. So you can also use auto as the special keyword for declaring a variable. In this case, num is equal to 15. So auto will automatically give it the variable data type as int because the value assigned is 15, which is an integer. Therefore, the number num variable will be given the data type of integer. We have obviously learned that we can use this for loop to loop through the array, but you also have this another range-based for loop where you can say data type, identifier, and the array name. So if we can say int and the counter and arrays ages, and you can write some statements. So you can have array like this where you have a double array of list, and you can say I have a variable called sum, which is the identifier. So every time I run it, I'm just summing the elements from my array into the sum. So this is an example of how you can use this range based for loop. Let's move on to the C string or character arrays. Character array is basically, if you remember from the beginning, character only can capture one element, one character, excuse me. And when you declare a character variable, it by default captures the value null, which is the \0, as you can see here. And this is the null character which gets stored in a char variable. So if you are, this is one character, but if you need to capture multiple characters, then we are talking nothing but character strings or character arrays, such as hello there or John L. Johnson and so on. So if you say char name 16, you're saying I plan to capture 15 elements in this character array, because the last element in a character array is always \0. So this is a key thing for you to remember. If a question comes where it says how many characters can you store in an array of 16 elements, the answer is 15, because the last element will always be \0. If you happen to use only the 5 elements, then so be it, but it will have the sixth one as \0, which is the null character. Here we have, you can use this. This is another example. This will give the length as 5, because we have JOHN and the null character. Here we can have up to 25 elements, because 26 is reserved. So if we have an array like this, where we are saying student name is 26, we cannot, the aggregate operations such as the assignment and comparisons are not allowed. So we can't just simply say, hey, this variable, I'm going to give it a value like this. This is not going to happen. Similarly, think about it. You have int list 16. Can you say list of 16 elements is equal to 10? You can, because you are saying this array is equal to 10. You don't do that. You say the first element I want in this array to have a value 10. So this is not possible. This is illegal operator. But you can use the string copy, string comparison, string length, some of those functions that we learned last chapter, to copy, compare, and check the length. This is what's been elaborated here as well. And here is an example where we are using a character arrays, and then we are using some of these functions to display the output. Since these are very much related to what you have done last chapter, I'm going to be very brief. If you have a character array, you can use the console input to get the information from the user up to 30 characters, after which it will stop accepting even if the user has typed something. If the user types, for example, you have an array of 31 characters, and if user type Ashish, then it will have the first elements with that name, and the data in the adjacent memory will be weird, corrupted, because it's just given some random values. So if you want to capture white spaces, then that's a different story. In order to capture a string entered by the user that has white spaces, we need to use the cin.get, which allows us to get the spaces as well. So if you have an array of 31 characters or 31 elements, notice 30 is what we can capture, because the last will have a \0, the null character. But we can use the cin.get with 31, and if the input is like this, then that exact thing will be stored. And if the input is much longer, then the only first 30 characters will be stored in our array. Some more examples of how you are doing. Now, if you are trying to capture multiple lines, for example, you want to capture 2 lines from the user, then we need to understand that when the user presses the enter, we need to discard it. So here's how one would do so. We'll get the first string from the user, when the user presses enter, which is the \n, we want to store it in a character variable to just simply discard it and then get the remaining into the next. So these are some small, very specific examples that one can that can get unnoticed if you're not reading carefully. But that's why I'm stressing the importance of these things. If you want to read and store line of input including white spaces, you can also use the stream function getLine. So we can use char getLine 100, which will read and store the next 99 characters or until the enter is pressed by the user, and the null character will always be added at the last character as follows. So string output, if you want to display the output, yes, we can absolutely use the output because aggregate operations can be allowed in cin and cout, as we learned for cin and we are learning for cout. But let's say you have a character array of 5 elements a, b, c, d, e, and you have x 50 and y 30 minus 30, and we are displaying the name. What's going to happen is it will display A, B, C, D, E, and then it will also display the next memory spaces after that because it doesn't recognize where to end. So the information will be continuously displayed out, and if you run it, you might see something different than what's shown here in this picture. So keep in mind there are different ways of displaying output, which we'll learn later. Let's say you have most of the code that you will write in this textbook requires you to have an input file and an output file. So if you have an input file and output file, you'll declare ifstream and ofstream, and you will have a file name, imagining that 50 characters the longest name. You will grab the value from the user, and then if whatever is the file name, you will try to open it, and if you will ask what's the output file name, you will capture it, and then you will create an output file with the name that is given. String type and input output files, this is something we have learned, where we have learned that we can declare string using the string and then do a lot of function utilization to compare and move and substring and do lots of other things. But mind you that a string variable is a bunch of strings, a bunch of characters, is not same as a character array. Okay, a string and character arrays are two different things, but when you are comparing a string with a character array, you need to change that string into a character array. So the header file string contains a function c_str which converts value of type string to a null terminated character array. So this is something you need to remember when you are mixing up between a string array and a character array. So if the user is asked to enter a name in a string variable, you will capture it, but when it comes to open the file, you will convert it with the .c_str function so that it has a null terminator in the end. When you're talking about parallel arrays, folks, keep in mind parallel arrays are two independent set of arrays, but when you're working with them, you need to make sure if you shuffle one array, you have to shuffle the other one up exactly same, otherwise you can have a mismatch. So this is, in my personal professional experience, I have not dealt a lot with parallel arrays because it's very difficult. If you move things around, you have to keep the index of the first array and then use the same things for shuffling the elements in your second array and third arrays that you may have. So this is somewhat of a topic which I personally haven't seen much utilization in real world. Here is an example of two-dimensional arrays where you are, this is an excellent example where you have different, the brands of cars and different colors in which they are available, and every intersection you are capturing a value. So you're saying Toyota in the gray color, there are 12 cars in stock, whereas BMW in black we have 13 cars in stock. So this is a very practical example of two-dimensional arrays. How do you declare it? You can see here you are just using two sets of square brackets and declaring the first as 10 and 5 as the second one. What it would do is it's going to create an array of 10 rows, just like we did with a single dimensional arrays. And here you have 5 columns which are 0 to 4. So the first element is the determination. The first position in your array declaration is the determination of how many rows it will get, and the second element will tell you how many columns it will get, which is kind of immaterial because when you're talking about multi-dimensional arrays, you don't have rows and columns, and you have to visualize in a three-dimensional way how my three-dimensional arrays or four-dimensional arrays will work. We will see that later in the end. So here we are saying find the fifth row and third column and set the value 25.75, which will set it in the fifth position in the third row, as you can see right here. Okay, in this example, to be honest with you, there is a little incorrect behavior, because when we are saying I'm putting in the fifth position, actually, pardon me, this is right. When you're saying the my row index is fifth, is going to start with 0, 1, 2, 3, 4, 5, and then 0, 1, 2, 3, and it will put the value as you can see here. How do you declare and initialize a two-dimensional array? You use sets of curly braces, as you can see. So we are saying I have 4 rows and 3 columns, and here's what's going to go in the first row, here's what's going to go in the second and third and fourth. It's slightly convoluted, but when you're writing, indent your code and you should be able to easily utilize the initialization of a two-dimensional array, which will set the values like this. We can also use enums. So if you have number of rows is 6 and number of columns is 5, we can have a car type enum for the 6 types of cars, and then color type for the 6 types of colors. And we can say I have an array which is number of rows and number of columns, and we can utilize in this manner. We can say int in stock 1 3 is 15 is equivalent to in stock Ford White is 15, given what we have done right here. Okay. In comparing these two, it would be much easier for somebody to write like this in order to set a value, in order to get a value, rather than 1 and 3, because they will need another printout on their computer to know what is 1 and what is 3 and stuff like that. So this is very intuitive usage of enum that we learned last time. Processing a two-dimensional array is very similar to processing a single-dimensional array, so you may kindly go through this. I'm just going to briefly touch upon it and move on. If I see anything important, I shall absolutely help you. If you're initializing two-dimensional arrays, the one thing that should come to your mind is you need to use double for loop or nested for loop. The one loop will loop through the rows and the other loop will loop through the columns, and every combination of rows and columns, you will set the value to 0 or whatever. So here we are doing matrix rows and columns 0, as to say every row, every value in my array will be set to 0. Okay. Printing as well, you will loop through the rows and then you will loop through the columns, and you will display the output at the combination of intersection of rows and columns. Similarly, if you want to set all the values in a particular column, in the column for a particular row, you will keep the row equal to 4, and you're just saying in this column from 0 to n, for every 4th row, this is the value. So sum by row, sum by column. When you are specifically working on a particular row or column, you only need a one for loop. So it probably is very intuitive. How do you find largest element in a row and column? This is exactly same as what you have done for single one-dimensional array, because here you are just saying I am not going through the entire matrix. I'm just going through either a one row horizontally or one column vertically. Okay. You can pass two-dimensional array as a parameter to a function, and they are passed by reference. So as you remember, so if you're passing a two-dimensional array, you need to keep in mind that you need to pass the array, give how many rows and how many columns are there, because otherwise you will not be able to process that function. You won't be able to know how many rows and columns are present. So here is another one example where we are passing an two-dimensional arrays. For the two-dimensional arrays, we are not specifying how many rows are there, but we are specifying how many columns are there, and then we are using the number of rows as another parameter. So what we'll do, we will loop through it, and we will loop the rows. The nested for loop will know the number of columns, and at the every intersection of rows and column we can display the output, which is what they are attempting to do, or we can sum if that is the intention of the application. When you are passing two-dimensional array, as one thing I want to mention, C++ uses the row order form. That is, the first row is stored first, followed by second row, followed by third, and so on. So this is something to keep in mind when you are trying to understand how the information is actually saved internally. Okay, here's another function for finding the largest in a row, or for every row, and how you can pass a two-dimensional array to a function is displayed in this example. So kindly go through it, just a couple of pages worth of material. Array of strings and the string type, array of strings and character strings. So some of the concepts that we have learned, you can declare a string array as follows. We have mainly dealt with integers. We have done a little bit of calculation based array utilization, but you can also have a string of list of 100 elements if you're capturing 100 types of products or 100 names or something like that. Suppose that the largest string, for example, name in your list is 15 characters long, and your list has 100 strings. You can declare a two-dimensional array of characters of 100 rows and 16 columns. So this is basically doing the same thing as well, whereby we are using a multi-dimensional character array to capture the information of 15 names, 100 names of 15 characters long at the most. Say, for example, as follows. And if your name is going to have spaces, do make sure to use scene.get and then capture that instead of just getting in from the user, because it will not accept spaces. How else can we declare? Two-dimensional array, you can have number of rows and columns. You can use type def. We are saying from now on I'm going to use the integer is also will be called table type, number of rows and number of columns. So anything I use table type, it's going to give me an array of 20 rows and 10 columns, and I can say table type matrix, just one statement like this, and matrix will be 20 rows and 10 columns. Why is this useful? Why type def is useful? When you are working in a company and you have to declare array using in a certain manner, you may say shelf space or FedEx layout in the warehouse, and those things may be useful than trying to do the same thing again and again and again, because if your warehouse is structured in a similar way, or you are capturing the information from the user in a similar way to display the statement, you always display 20 rows and 10 columns no matter what. So you can have these things standardized and you don't have to keep repeating it again and again. Multi-dimensional arrays, you can have n dimensional arrays as follows. Keep in mind, we just need to make sure when we are getting the values and we are setting the values, we are using it appropriately. So let's say you have car dealers, 10 by 5 by 7. Imagine 3 layers. The total number of components in this array will be 10 times 5 times 7. So that would be 350 elements is what's going to go in this array. As I said to you earlier, if you have another multi-dimensional array with 10, 5, 7, and 2, you're talking about having 700 elements because you will be multiplying this with 2. And if you want to set a value, you will use the 3 indices to set the value. To get the value, you will use the 3 indices as well. If you have 3-dimensional arrays, in order to reach one element, you need to use 3 nested for loops as shown here in order to get the value, in order to set the values. Here is the example which summarizes pretty much the whole thing, whereby if you, this is somewhat of a little, I'm sure some of you will find it very useful, but when you're sending a code message from one computer to another, or you're sending a message from within an organization where you want to keep it secret, you send the same message twice, make sure the recipient receives it and can decode it. So this is an example that the textbook uses to connect all the pieces you have learned. There is problem analysis and algorithm, how it will run, how you will read it, read the file, create an array, and utilize the algorithm to find if the message is correct or not. So kindly go through it. This is very self-explanatory. It kind of summarizes everything for you. Another example for text processing, where how the text, we can read given text, output text, and print the number of lines, number of times each word or each letter appear in the text, and uppercase letter and lowercase are treated as being same. That is, they are tallied together. And now they are using the 26 alphabets to write this code. So again, I've summarized most of what you see here in this chapter, except for these last 2 comprehensive projects, which can be really copied into Eclipse for C++ or CodeLite or DevLite or Dev C++ or any other software, and see how the output works. You have the quick review at the end. You are asked to do programming assignments number 2 and 3 as shown here. So these are what you need to do. Programming assignment number 2 and 3 on page 602. They are very related, folks. So keep in mind, I have purposefully picked them because they are related and they should give you confidence in working with arrays. The number 2 is write a C++ function, smallest index, that takes as parameter an int array and its size and returns the index of the first occurrence of the smallest element in the array. Also write a program to test your function. The other one, which is number 3, is similar to the 2, except that we are asking about the last, not the first, the last largest index position, the last largest index to find the last occurrence of the largest element in an array. So you are going to start reading an array from the backwards. Okay, you will read the last position and then go previous and previous and previous to find the largest element. Just to give you a very brief idea, so finding the smallest index, obviously you'll use your IO streams and declare the namespace. You will have an array of, let's say, 15 elements. Declare the functions that you'll be using. One would be to print and one would be to find the smallest. So you have an array. You are printing the array just to make it comprehensive, and then you're going to find the first occurrence of the smallest by utilizing a function as requested, and then you can also list the value, what is that present, by using the array, passing in the index sent by this function. To print, this should not come as a surprise. You are getting an array and the number of elements. You are using a for loop to simply just loop through it and displaying the output one at a time, separated by a space. To find the smallest index, you say, let's imagine that the first is the smallest, and you run the array. If the element in your smallest position is greater than the next position, then you just set the counter to that one, keep looping through it until you find the min index. So this is what you need to do for the exercise 2. For exercise 3, you have the large index where you have an array. You're passing the largest index. You have an array and that is passed to this function which does the job. So The print again should not come as a surprise. You're just looping through the array and finding printing all the elements. The largest index basically assumes the last element is the largest. So if the size is set as 10, you're saying that the ninth element, because 0 is the first one, is the largest. And you say keep running until the counter is more than equal to 0, and you decrease the counter every time. And this is how you're using to find the largest index or the largest element of the array. So this should be the largest element of an array, not the smallest. Hopefully, this should give you some perspective on what we have gone through to see how to use array. Hopefully this chapter that we have done has exposed you to arrays. If you were not familiar with arrays, how we can use arrays, and given you some practical advice. The information for this video will be posted under week 4, similar to week 3, where you have assignment aid and a video lecture plus assignment help. I will have assignment aid in week 4 and week 5, which will allow you to watch this video that I'm making for you and complete the quiz assignment as well as the programming assignment for chapter 8. If you need further help, please reach out to me. My information is on the homepage. Please complete the assignment on time so you get full points. I shall create a video for the next chapter at the right juncture. Good luck, and let me know if I can be of any further help.